Now that we know the basics of factoring, we're going to use factoring to solve quadratics. So when we're solving quadratics, we're looking for wherever the quadratic is equal to 0 or wherever the parabola crosses the x-axis. And there's a couple different ways this can happen. In the first scenario, it can cross 2 different times. So because it crosses 2 times, there's 2 solutions. That's the most common one. But it's also possible that the parabola only crosses once, so it kind of bounces right off the x-axis. That would have only one solution. Then it actually is also possible that it never crosses at all, and this would have no real solutions, and that word real is actually important because there's such thing as an imaginary solution, and we won't learn that in Algebra 1, you'll learn that in Algebra 2. But there are such things as imaginary numbers that make these quadratics true. So we can use factoring to find what those exact solutions are, to find out where those parabolas cross the x-axis without obviously drawing it every single time. And in order to do that, we're going to have to use something called the zero product property. The zero product property is actually a property you probably already know, but you don't really know it as being called the zero product property, and we haven't really used it. So it says if the product of 2 factors is 0, then at least one of the factors is 0. So that's just going off of the fact that anything times 0 is 0. So if we have 2 things being multiplied, which we have when they're factored, we have 2 different factors. So if they're both equal to 0, then that means one or the other must be equal to 0. And we're going to use that to solve these quadratics by factoring. So in this example, we have a quadratic that's already factored. So we have 2 things being multiplied, and it's already equal to 0. So that means we can use the zero product property. So the zero product property says if something times another thing equals 0, at least one of those 2 factors has to be equal to 0. So we're going to find the solutions by taking each factor, so x plus 4, and then 2x minus 3, and setting those equal to 0 individually. And that will give you the 2 instances where this entire equation is equal to 0. So now we just have to solve those 2 equations. And it ends up being really easy because they're only 1 or 2 step equations. So for the first one, we subtract 4. We get x equals negative 4. And for the other one, we add 3. We have 2x equals 3. And then divide by 2. We get x equals 3 over 2. And that's it. Those are our 2 solutions. And you could, if you want, and it's really not necessary for these, but you could actually check these answers by plugging them back in. So if I plugged in negative 4, I would have negative 4 plus 4 times 2 times negative 4 minus 3, and that ends up being 0 times negative 11, and obviously 0 times anything automatically equals 0, and the same thing works over here. You end up getting 0 equals 0. So that's what we're going to do in this entire first section. Now, the only other kind of example that comes up is if we have like a GCF out in the front, but it works the same way. So you want to take that whole first factor, set it equal to 0, and then take the second factor, set that equal to 0 as well, and then solve from there. So we end up on the left side, we have to divide by negative 3, and just be careful. A lot of people actually just forget to do this one completely, but you do get an answer. It's 0, but that's fine. That's still a possible answer. So we get x equals 0, and we get plus 7, x equals 7.